Hello and welcome to the Secutopia demo of the Secutopia X1. In front of me we have a Xilinx Ultra 96 SoC FPGA board, which houses the FPGA logic for the HIDS system. In this demo we will be presenting how the HIDS system works and how it can defend against two attackers, the Raspberry Pis. The Raspberry Pis will be running a denial of service attack on the board, and the board will show up on a screen in the web app the attack happening in real time and its detection. So to start off this demo, we're going to be launching the web app we created for the Secutopia X1. The reason we created a web app in phase 1 was to visualize what's happening on the board as it's being attacked. We can see in real time that it's detecting these attacks on this web app. So in order to begin the web app, we launch the backend first using the command node app after navigating to the web app folder. So now you can see it's listening on port 4444. This allows it to open up the port so we can connect to it from the Secutopia X1. And we launch the web app itself. We can see it here. Now it's waiting for a connection, and this is the web app. Now we move on to the board where we can set up a connection with the web app. So now we're working inside the interface of the Secutopia X1. It is running Jupyter Notebook, and in this part of the demo we're going to be launching the IoT socket server and protect it using the HIDS. The HIDS will detect any attacks coming into the IoT socket server, and the IoT socket server will give a place for the attacker to send his denial of service attack. So we'll start off by obtaining the IP address of the board. We can do this by going into the terminal of Jupyter Notebook and using ifconfig. So we can see the local address, the USB through Ethernet address, and the Wi-Fi address. This demo will be running on Wi-Fi, so we'll use the last one. So we go back to our main page. And we launch our IoT socket server program. And now we'll need to input our IP address into the binding. And then we run. And now from this point, the socket server is running, and we can test it by using the IP address and the location of the port. So if we go here, we can test it. And we can see the server is now running. This will be the port where the attacker sends his denial of service. So now that we've confirmed that our server is up and running, we now need to set up our hardware intrusion detection system. To do that, we go back to the Jupyter Notebook. We navigate to HIDS Demo 1. Now here's the entire program, including the FPGA portion of our demo. In this first portion, we set up the address locations for our system. Second portion, we send in the weights, and then we send in our packet header features. And part 6 extracts the features. We will need to make some modifications to this part in order to get it working. So we scroll down. and we enter our IP address for our computer. And the same socket that the web app is running on. And then we set up our host, which will be the board server. And we can see before running this, the web app is still running in the background. Once we run this cell, it'll establish a connection with the web app. So now we can see that the HIDS system is running and connected, and we are now monitoring all network activity on the Secutopia X1. Now that our Secutopia X1 is connected to our web app, we can see that currently there are no malicious connections to the board. All connections are showing status normal and are green. When the HIDS detects a malicious connection, the status will change to either DOS, probe, or R2L, and we'll give it a classification as an attack. So today we will be testing the DOS functionality of the HIDS by performing a denial of service attack on the board. We will be performing the attack on this computer for demonstration purposes, but it can be run on any computer that can run a Python program, such as a Raspberry Pi, as we showed earlier. So here's the denial of service attack program that we will be running against the HIDS in order to perform an attack. You can see as soon as we start running the attack, HIDS instantly begins to classify all of these spoofed IP addresses as attacks. And if we leave it running for a little while, we can see that it's flooded. We can also get more information from the attacks on the web app, such as the IP that's spoofed, the flag that we get, and the status, which is the classification that HIDS gives to the attack based on the features. So now if we stop the attack, all connections will go back to normal after it finishes sorting the last of the attacks. And it finished sorting all of the attacks, and all connections are back to normal. That concludes the demo of the Secutopia X1.